Hello, good afternoon, everyone, and thank you for joining us for our webinar today. Hybrid and electric vehicles, train, repair, and earn with Delphi. So I'm joined here today with Philip Michell, Technical Services Manager at Delphi, part of the BorgWarner Technologies. So before I hand over to Phil, I just wanted to go over some housekeeping with you all. So this meeting is being recorded and the recording will be available to you within a week or so. We have a Q&A function, so please, if you have any Q&A and any questions, please submit them in the Q&A function below. We will have a Q&A session at the end. And if we can't answer all of your questions during the live session, then we will be sure to get back to you offline. Perfect. Okay, so without further ado, I'd like to hand over to Phil, who will take us through the presentation.
Thanks, Georgia. You'll see my slick point now, but I'm just saying hello to another member of staff. So listen, thank you. Good afternoon. Thanks for joining us. As Georgia said, my name's Phil. Like the guy from EastEnders, but with a little bit more hair. And I'm the Technical Services Manager for Delphi Technology as part of BorgWarner. And the kind of idea behind today is just to cover a few topics. Now, hybrid and electric is a huge, it's a huge topic in itself. And of course, there's training courses on it, there's different levels, and it's a lot to go through. So what I thought about this afternoon is just to sort of focus really on a few different points on that. The first one is a little bit of safety, which I'll touch on a little bit of technology, things that you may not yet be aware of. We also get asked quite a lot by customers and distributors and technicians on the different levels that are available for training. And some people find them a little bit confusing. Should I be on a level 1, a level 2 or higher? So I'm just going to touch on the different levels. And I'm just going to mention a little bit about who should take what level and which level is suitable for kind of which person. And then I'm going to finish on servicing, mainly around electric vehicle servicing. So what I'll be doing is be doing a live connection to a vehicle in our workshop, which is down there behind me. It's one of the reasons I've still got to have the doors open because it's a Bluetooth connection. It's fairly far, but fingers crossed that part goes right. So we're going to connect to a vehicle live and give you an idea of the kind of items that you would do maybe when you service a vehicle. So I apologize for any of the noise in the background. I've got to have the doors open. But we'll make a start. So just a quick run through on EV safety, just to make you aware of a few things. That when we talk about safety, we're talking about voltages of all levels. Now, traditionally, our hybrid vehicles of the past, the days of your original Priuses, tend to run at around about 200 volt. But things have changed since then, and the voltage has actually gone both up and down. We look at our mild hybrid technology that is actually ranging from 12 to 48 volts. So some Audis will use a 12 volt mild hybrid. That means they've got a 12 volt normal battery and a 12 volt lithium ion battery on the same vehicle. Some of the Mazdas are using 24 volts for them M hybrid systems, but the majority of manufacturers for mild hybrid are in the 48 volt range. The reason they do that, of course, is below the 60 volt threshold, there's different regulations on how much insulation you have to put in the cabling, and therefore it makes it a little bit cheaper to do so. So that's kind of the mild hybrid. Our full hybrid and our plug-in hybrid are quite similar, anything from around about 200 to 400 volt. Now, these are both AC and DC systems, and that level of voltage it does give us some level of risk. Now, my ethos on this is if you're got the right training and the right knowledge, you should just continue to work and service and repair these vehicles like you would any other vehicle. It's almost very similar to when Common Rail came around and it was all high pressure, don't touch it. But actually, once you were trained, we just deal with them like we do any other vehicle. Electric vehicle is where the voltage steps up a little bit. So they tend to move from around about 350 volt up to the later systems, which is 800 volt with the odd 900 volt vehicle appearing on the road today. So it kind of does sort of possess a different level of safety. And it's not just the voltage, because we're also dealing with AC and DC on the same car. So we have to be aware of what's three-phase AC, what's DC, And it's not always the components that we think of. There may be more as well. Many different motors on the vehicle, although they'll have DC cables going to them, they have three-phase inverters on board, the actual components, which switches it inside. So it just gives us that level of voltages, which could, potentially have a safety risk. And not only do we have the voltages, but we're also looking at multiple voltages on the same vehicle. So an example of a vehicle we have here, which is an electric vehicle, it has the normal 12-volt architecture for everything on the vehicle, the instrument panel, the heated seats, and all that sort of stuff. We have a 400-volt or a high-voltage battery pack powering the different motors and everything on the vehicle. And we also have a 48-volt active anti-roll bar system. So multiple voltages on the same vehicle with different colors on them. So traditionally, the 400-volt, the higher voltage system will be an orange color. The 48-volt system will often be a blue or a purple color, and then the 12-volt system, which is what we're used to. But we're also going to add a fourth one in there, because just because the battery is 400-volt doesn't mean that the motors are that voltage as well. Some of them are higher voltage than the batteries, in which case we have to have a step up, and others are lower voltages, so they can maintain performance even as the battery voltages drop down. We can just get a slightly better performance on them. So potentially 3 to 4 voltages on the same vehicle. And it's not just the safety aspect, it's the knowledge aspect about what you should expect to be seen when you're testing and repairing these components. So safety is a big thing, and it's one of the reasons that we have so many different training levels. And what I've done is I put the training levels, split them. So you've got on the left-hand side of the screen, you've got all of the light duty qualifications, and then the two on the right-hand side with the H next to them are referring to heavy duty. So from an IMI's perspective, and we're an IMI center, we are delivering the different levels on the left-hand side, 1, 2, 3, and 4. You'll notice that there are 2 levels of level 4, and I'll come to the difference on them. And then for the heavy duty side, where we're starting to see more and more interest now, because manufacturers like buses, trucks, short drop are starting to move into electric or hydrogen fuel cells. So we're starting to see that come, and we have got the levels available for that as well. So I'm just going to spin through each one and give you a rough idea of what each level is and really who should be doing it. And we're doing it really to follow this IMI's tech safe, which I genuinely am a supporter of. It really scares me when you see social media posts, whether that be Facebook or Twitter or LinkedIn, well, just having a go at this. And you think, not only do you really not know what you're doing, are you really being safe? It has to be our #1 priority. Second one, of course, is making sure the vehicles are service maintained and fixed, but also, are you actually making any money? Because ultimately, most workshops exist because they're businesses. And if you are trained correctly and you're good at it, that's how you make money. We're not just doing it as a really nice exercise. So let's start off first with level awareness. Now, from us, this is a 1-day course, and it's really aimed at people who would encounter vehicles. They wouldn't necessarily work on them. So they encounter them, they would talk about them, but they're not really looking at touching them. So people like valeters, front of house staff, salespeople, those are the kind of people that you would have on a level 1. And that means then when a customer does come in and ask them about servicing or maintenance of an electric vehicle, they don't just look at them like rabbits in a headlight. They're like, right, I understand a little bit about them. Let's talk through your problem, what the issue is it just a service? And they can go from there. And genuinely, I think that more sales staff need to be trained at this level. Really to try and cover some of the differences. I mean, we've seen a bit of an increase recently of non-Tesla vehicles being bought from dealerships and different brands and being told that they can charge at Tesla supercharging stations. Now, what that means is the person who was selling that vehicle didn't really understand what that meant. They've heard from somebody else, yes, they can use those charging stations, and not really understanding that there are different types. We also see people pulling up at a rapid charger using the wrong connector and realizing that after an hour of charging, they've only gained about 2% of battery because they're using the wrong connector. Unfortunately, there are multiple connectors at the rapid charger that will fit your vehicle, depending on your vehicle, of course. So it really gives that awareness. Level 2, hazard, and there are two different levels. There's level 2 hazard and level 2 full. Hazard really is aimed at people who are doing recovery, but they're also for people that want that little bit more than level 1, but don't really have the background of a technician. They don't have the vehicle electrics knowledge. They don't have the mechanical knowledge quite so much, but they need more than a level 1. They do need to talk in a little bit more detail about them. Or, for example, they are a recovery driver, or we've done some police as well. We're looking at compound staff after vehicles have been involved in accidents that are being stored correctly. So the level 2 hazard gives them a deeper understanding and gives them that confidence to be able to get to that vehicle, recover it, make sure it's powered down. If that's not accessible, what do they do about it? But level 2 hazard doesn't really give them the skills and knowledge to be able to actually work on them. So not start disabling the vehicle, don't replace components. That's not really what the level 2 hazard about. That's more really on the level 2 service. So it gives them that much deeper understanding. It gives them the ability to be hands-on and to be able to disable the high voltage system. And it allows you can work on the vehicle once it's disabled, but not really working on the high voltage system. So it might be you have to disable the vehicle to get to an item that's very close to a battery and inverter, and you just want to make sure that you're safe. It could be somebody, and we do lots of different businesses as well, but somebody who has to give almost a sign-off certificate to say that vehicle's powered down, so work can commence on it, and then they can recommission that vehicle as well. It doesn't really cover working on the high voltage system other than the disabling process. So it doesn't cover replacing components or anything like that. That's really where the level 3 comes in. So it gives a much deeper understanding. It get them to disable the system, but then they can also test and replace parts, and they can recalibrate modules. Let's say they fitted an inverter, so they've powered the system down, they've replaced the components, they powered the system back up, and they've had to do any sort of calibration or coolant bleeding or anything else required to get that component. But the one clear part of level 3 is it means that you don't work on a live system. So at no point should you be inside a battery, because that's live. Even with service plug pulled, there are elements of the battery which are still live. You also don't really work on the vehicle when the vehicle is live. That's really where level 4 comes in. So level 4 is giving you that full understanding. Moving on from level 3, it gives you the ability to test, diagnose, and repair. It means that you can work on a system live. So is there a charging fault with it? Is there an overcurrent error? All of these different issues, they need to be tested when the car's live. And it also covers battery diagnosis and testing of cells, testing of modules, understanding how the exact configuration affects their performance, and ultimately repairing batteries or cells or modules within a pack. And the real thing with this is people ask about different levels, and I say, well, let's forget hybrid electric for the moment. Let's go back to a normal vehicle. That if I was to bring a vehicle to your workshop and I said that the rear tail light bulb doesn't work, what would be your process? Well, the process would probably be first, providing you get to it, would be a quick check of the bulb, just to make sure the bulb hasn't blown. So what you've done is you've switched the ignition off, you've tested the component first, you've switched the ignition off, checked the bulb, put it back, and re-put the ignition back on and tested it. That's almost like a level 3 standard. You're disabling the system, although it's not high voltage, you're replacing the component and you're re-enabling it. But if it wasn't the bulb, what would you do next? Well, you'd probably have to either do a manual power up with your diagnostic tool, or you do a quick power check at the circuit to make sure you've got voltage feed to the bulb. That's a level 4 standard in the equivalent of hybrid electric. So I genuinely think that people are going to need level 4 far more than they realize, because level 3 is going to enable them to do a part of it. But level 4 really is going to be, it's just going to make sure that they're confident. It really does. Now, when it comes to servicing and maintenance, let's think about things that compared to an electric vehicle, compared to a combustion engine, whether it's petrol or diesel, what is it we're going to lose? Well, on the whole, we're going to lose oil and filters. Now, there are a few caveats to that. We still have a lot of transfer oil and potentially differential oil, and the odd vehicle does have some filters as well. Mercedes, for example, use a filter in their battery pack. It's a desiccant filter, and it's used for removing moisture and stuff from the pack. We also have other filters on transfer boxes or differentials from an electric vehicle to the road wheel. But on the whole, all of your traditional Orlan filters, they're going to vanish. Ignition systems are going to vanish as well. Sensors will have a dramatic decrease. Yes, we do use resolver sensors on the motors. We do use lots of temperature sensors and current sensors, but on the whole, around cam sensors, crank sensors, on phasers, oil pressure sensors, the majority of those are going to, they're going to go. We're also going to lose everything related to the exhaust system, whether it's the complexity of DPR and selective catalyst reduction with AdBlue, lean NOx cats, all of that complexity is going to disappear when it moves to electric vehicles. But what's going to be the same? Well, steering suspension will likely remain unchanged. In fact, to deal with some of the extra weight, we may see an increase in bushes and suspension wear. We'll also see some more complex systems becoming more mainstream to try and cope with the weight. So active anti-roll bars, adaptive air suspension, just to try and hide the additional weight at the moment. Now, I've put braking there. Now, traditionally, you'll have heard that braking will diminish greatly with electric vehicles, and that's partially true, but there are elements of braking that we're going to keep. And I'll give you some examples. We're seeing at the moment now the electric vehicle market is beginning to mature slightly. We're able to get a little bit more data. We're seeing extremely bad corroded brakes. So the physical disc surface, I drive an electric vehicle, it's 12 months old, and the disc surface is already completely scored and rusted. And that's the surface that the pad contacts, that isn't a non-contact surface. We're seeing calipers and brake pads being seized in their holders because they're just not used as much because we have regenerative braking. So we are going to see a change in braking, but we're going to start to see disc run-out issues and disc thickness variation issues purely because of the lack of use. But what's really going to increase? So we're going to lose the ignition inside. We're going to still gain the steering suspension. And what is it we're actually going to gain, or extra things we might have to do? Battery checks, which is one I'm going to come on to. I'm going to do a quick live check on the vehicle. We're going to be looking at specialist replacements. So being able to open components up and going back to basics a little bit and repairing components inside other components. These sort of new faults. So we're used to dealing with ABS issues and DPF issues, and now we're going to be dealing with charger issues and low voltage issues around the high voltage system. So it's something to be cautious about, but actually quite excited that we're getting a new technology, and it's a technology that's going to keep us going forward. So what I'm going to do now is, rather than continue with the presentation, I'm going to go and move directly to the diagnostic tool, and I'm going to communicate with the vehicle and just give you an idea to start with on when we service these electric vehicles, and this goes for plug-in hybrids as well, is what should we be doing that we're maybe not doing already at the moment. And I'm going to focus on the top one on the right-hand side, which is battery checks. So we do a lot of training. I mean, today here in the technical centre in Warwick, we're doing 2 level 3 courses simultaneously. We're seeing a massive demand, a real uptake of workshops. And we do a lot of them. We do a lot of people. And it's quite often that I'll ask customers, look, has anyone ever serviced an electric vehicle? Yes. And some customers say, yeah, we're seeing a few in the workshop. We've got a couple of the early Leafs, the early Zoes, the original IMEVs, and those earlier vehicles. We're starting to see a few trickle into the workshop. They're not in big numbers, but they're coming. And we noticed that if you look at some of the service sheets, so these are the OE service sheets. And what I'm going to do is I'm going to show you one as an example here. So I'm going to load up our diagnostic tool, and we're in. And I'm going to type the registration number of the vehicle that we're going to connect to. Get the reg in right. So this is our Nissan LEAF that we're going to connect to now. We've got a separate section here for electric vehicles. So these are all of the electric vehicle modules that could be fitted to that vehicle. But what I'm going to do first is I want to have a quick look at the service sheet. So I'm going to go into Delphi's technical data here, and I'm going to click on the maintenance function. And I always say when demonstrating diagnostics, it's like working with children on TV. There's a hit and miss whether it ever actually works, especially as we're trying to comms with a vehicle much further down there. But so far, so good. So here's the service schedules here. So we've punched straight out into the technical data system. normal conditions, and let's look at the first service. So I'm going to zoom it in just a touch, just to make it easier for you to see. So here's the 12-month service. Let's have a little look at this service sheet. It's 1.3 hours to complete the service. And there's, in the additional work, there's items that we're probably not really going to do on the first service, with the exception of that one, which is replace the pollen filter. So that's once here, that's fine. The rest of it, coolant, 54,000 mile, 5 years, brake system every 2 years. So really, we're not doing the additional work. And what I'm going to do is I'm going to scroll all the way down in the service sheet. And this is the OE service sheet as well. And we move to the electrical system. Now you can see here on the electrical system, we have a number of items, and I'm going to miss the top one for the moment, but we're going to carry out a diagnostic check, read the fault codes, fairly common. We're checking the function of the lights and the headlights and the interior lights. We check the battery charge of the high voltage battery, and we check the charge port just to make sure the connection's open, there's no corrosion within any of the pins. But the top one says, check the high voltage battery report. And what we've done is, when we've asked technicians and garages that have actually serviced this vehicle, and this is any LEAF from around about 2012, 2013, we said, have you serviced one? Yes. Did you follow the OE service sheet? Yeah, I did, absolutely. So when we brought the OE service sheet up, we showed them that and we said, what did you do? And the answer genuinely, normally, is, I just ticked it because I didn't know what it was. Now that's two issues. Number one, that's not the way, that's not the correct methods. But number two, they may be missing out on something that is going to cause problems either now or later down the line. So what I'm going to do is I'm going to give you an idea of what this battery usage report is. There are two methods to getting a battery usage report, and I'm going to come back out of the technical data and I'm going to head back to the diagnostic tool. Now, what we're going to look at to start with is we're going to communicate with the high voltage battery directly. So here I can see it there, the high voltage battery, and we're going to communicate directly with that high voltage battery. And this will take a second or so to connect, just because we're fairly far away. And I'm presented with the main screen. Now, for anyone that's not seen the Delphi Diagnostics tool before, we have the icons down the left. We've got fault codes, erase fault codes, live data, and activations and programming. So let's quick look at the fault codes. No, there's nothing there. And on the activation side, we've only got option for the relay heater unit. So what you'll see is that we don't have any function to be able to run an automated health check. So there are two options. There are either the automated function, which many vehicles have, and I'm going to show you those after we've done this one. And then we've almost got the manual method if your diagnostic tool doesn't have that feature for that vehicle. Now, the Delphi tool has got the feature from a lot of vehicles, just doesn't happen to have it for this Nissan LEAF. So what we do in this situation is we kind of do a standard health check, and we look at a few items. I'm going to go through those now. So on the left-hand side, you'll see all of the live data that we can access, and the right-hand side is all the data that we are going to access. So we're going to start off first here. Just bring that back in with looking at some of the voltages. So I'm going to put in first the electric current, and I double click it and it comes to this side, and that's the one that we're actually going to look at. I'm then going to look at the maximum and minimum cell voltages. So that looks at all the batteries, all the modules within the pack, and says, right, which one's the highest and which one's the lowest, to give us that voltage difference. And then also, it'll be nice if we could find out the actual total voltage of the pack at the moment. So I've selected my 4 parameters as the first step, and then we're going to have a look at that data now live and see what it looks like. So you can see at the moment that the battery is at 372 volts, just over, and we can see the minimum and maximum voltages are here. Now, rather than me having to look at all the cells and try and calculate the difference, that's the idea of this. It just makes our life a lot quicker. So I'm noticing at the moment that we're about 869 and 886. So we're on average, we're about 15 millivolt difference between that number and that number. Now, generally, what gives us areas of concern is if it's around about 35 to 50 millivolt. So about 35 to 50 millivolt covers most manufacturers, not all, but a good proportion. So If the voltage between the min and the max is greater than that, then there's a potentially it's going to start to give us a little bit of a problem. And then what we would do is we would check all of the cell voltages to find out, is this common across the whole pack? Is the whole pack just aging? Or is there maybe one or two modules that are suffering issues and the rest of them are all fairly close together? So if we had a 50 millivolt difference, we could have, 90% of the modules are only 30 or 20, and then the last few are causing the problem, in which case it then may be worth moving into a diagnosis and repair stage by removing the battery and doing it that way. If they're generally all aging, then that's a little bit more difficult. So that's the first part of the health check we're able to do on the battery. This one is looking like a good battery. This is a 2019 car, and we're only looking at around about 14, 15 millivolt difference. So that's good. The next part of the health check is talking customers really through about how to look after their batteries. Now I know they're covered by a warranty, but that warranty may only cover 70 to 80% of each charge within a 5 to 8 year period. The more battery life you've got left, the greater the range of the car usually. So what we're going to do is I'm going to press this car button here, and that's going to bring us back out. And I'm going to stop communicating with the battery module, and I'm going to communicate with another module that also monitors the charge points. So I'm going to come into here, this one, which is the EV and hybrid electric system. And I'm just going to communicate with that module. And what we're going to do is we're going to give the customer an idea of how their battery is doing, and also what they could do to look after their battery more as they go through. So quick run through here, we've got fault codes, we've got no codes in the system. You'll see now we've got an additional button in this module. This is our programming module. So to give you an idea of what's in there, this is if we were to do a battery replacement, we would have to clear the data out of the high voltage junction box, and we'd also have to clear the data out of the instrument panel, so we get the range back on this particular Leaf where it's displayed on the instrument panel. But at the moment, I'm going to go back to our live data, and I'm going to ping across a few different items, and we're just going to scroll through them. So what we're going to look at is the remained energy. We're going to look at the battery voltage as well. Let's look where that is. There. And then the other ones we're looking at is about charging. So I'm going to put charge in there, and it should just filter that down. So I'm interested in this one, the normal charge count from the time the car was new, and the quick charge count from when the car was new. So these four items are going to tell me how much energy is left in the battery, and also how many times has it been slow charged and fast charged from when the vehicle was new. Now, trying to advise customers on constantly, repeatedly rapid charging your battery will most likely reduce its service life, and it will begin to degrade faster. So it still may not hit below the 70 or 80% of the warranty, but it'll be probably closer to there. Now let's have a quick look at this vehicle. It says that we've got 70% left in the battery. And just to note on that, that you will always see a difference between that value and the value that's displayed on the dashboard. And that's because they display a corrected value on the dashboard. So for example, when the dashboard reads 0%, you'll still see 10% actually of energy left in the battery, and it's designed as a safety aspect. So we recognize we've got 372 volt. We realize that on this car, the type 2 connector, we've plugged in and charged that vehicle 181 times. We've done it from a quick charger 132 times. So by that, we can do the math and give the customer a calculation on a percentage, how much of their vehicle is spent, how much of their charging is spent under rapid charging. Now, the vehicle that we have is an ex-dealer demo, and they only had a CHAdeMO rapid charger at the dealership, the Nissan dealership. So this one is considerably high. When you look at most customers' ones that are charging the majority of time from home, the ratio is far different. You usually have a lot of normal and then only a few on rapid charging. But we would advise the customer, and we'd print each one of these off. We'd give it to the customer as part of the service and say, look, your battery health looks good. Just be aware that you are rapid charging a lot, and it's more of an education thing during that service. And the difference in confidence that the customer, you can give the customer that, rather than just a tick service sheet where you're just ticking it and it's an exercise and you've done a quick check on the brakes and everything else, screen wash and pollen filter, all sort of looks good. So that system there, excuse the noise in the background. That system there is if you haven't got an automated function, you've just kind of got a manual function. And what I'm going to do now is I'm going to disconnect from that vehicle, come back to the top, and we're going to have a look at a few other vehicles that have an automated function. So we're going to start off one first, which is going to be, let's have a quick look through my pack. Yeah, we're going to have a look at a Kona first. So if I scroll down into the list, and I haven't got a reg, but if look at this, where are you? There we go. So if we look at a Kona electric vehicle, and we can pick any of the years, I scroll down to electric vehicle part. So this is where all the electric vehicle modules are. And we're going to go to the hybrid electric battery system, the BMS. Now, there's a nice part of the software. It enables us to look at items before we actually plug in. So I don't have this vehicle here. And what I'm going to do is I'm going to click on the vehicle information tab. And you can see I've got it selected here, Kona 2019 electric vehicle, same as on the other screen. And I'm in the hybrid electric battery management system. We're going to open that up. And you can see here we've got test battery state of health. So I'm going to right click on that and I'm going to help. And that will give us a little bit of a help file telling us what that's about and what's it to do. So on this Kona, for example, we've got an automated function where you just run the function and the battery management system will report on the state of health of the battery and give you a short report automatically. And then that's what you would give off with your service sheet as part of servicing this electric vehicle. It gives an idea here of what's to happen. You've got to be above 10 degrees, so there's no good doing it in the middle of winter outside. And on this one, the high voltage system needs to be active. So the car needs to be in ready mode, so fully powered on. The main relays have activated and you're in ready mode. So great. And when they're like that, it really is so much easier. So let's look at a different vehicle. We're going to look at Mercedes next. Where are we? We're going to look at a C-Class, 2016 C-Class. We're again in the battery management system. So not the lithium-ion battery directly, but the actual battery management system here. I'm going to press the information tab. And I'm going to scroll out. Which one was it? The top one. Now you notice here that as I'm filtering out on here, we end up with these different system variants. And I just want to explain what those are, because you know, if you sometimes connect to a vehicle and the diagnostics tool seems to take a long time to connect. On this vehicle, on the battery management system, there are 4 different potential software variants. And what the diagnostic tool has to do is it has to go and check each one to determine which software variant. Now, actually 4 is quite a low number. If you take some of the Renaults, they can have 30 to 40 software variants. And in the background, the diagnostic tool has to go, are you variant 1? No. Are you software variant 2? No. 3, 4, and progress down. So that's why sometimes it can take a little bit longer to connect to a vehicle. And of course, it's usually always the last one. It also changes, so the functionality may change depending on what software variant that you have. So if we look at some of these, we've got a test, and there we go, we've got battery check. And we can see the help file on that. And it's used, this function here, I'll zoom it in. The function is used to test the available capacity of the battery. Again, just got to be above 10 degrees. And this is a function that is already in the battery module. The diagnostic tool simply activates the function and grabs the report once it's done. As I say, these are far easier to do, and they are generally more accurate as well, because it's already a preset function that's run in the diagnostic tool. Now, the other option, of course, is not just from a service perspective, but what during a service or general maintenance work, what additional items would you be able to do for a customer that you couldn't do today, for example, on your combustion engine? Well, I'm going to head over to a fairly common car at the moment, which is the Mitsubishi Outlander PHEV. So let's have a quick look. That's the one. So Outlander plug-in hybrid electric vehicle, really sort of common 4x4 SUV. And I'm going to come down here to the electric vehicle part. And I've got there the battery management ECU. Same procedure, click the I button. And we're going to come in the battery management system. and we're going to come here. Now, what we've got here is a couple of different adjustments. We call those adjustments, they're programming or calibration. Is you've got an automatic capacity measurement of the battery. That's sort of the health check. You've got a battery maintenance function, but I want to focus on this one here, which is cell voltage smoothing. So I'm going to load up the help file to look at it. And it has here that this function is used to smooth out the battery cell voltage. It can take up to 2 hours to complete. Set the vehicle to ready mode and activate it. And the whole idea of these two functions here is battery cell voltage smoothing and also battery maintenance function. Or is it that one, or is it measurements? That's the measurement one, that's it. So you can see here that when doing cell voltages smoothing, you can offer almost a service to try and reclaim some of the energy back that's lost through voltage balancing. So because a high voltage battery is full of little small batteries or small modules or pouches, depending on the design, then they're all going to discharge and charge at a very slightly different rate. Now that's fine for the first few thousand miles, but as the car ages and gets older and older, those levels are going to start to tip further and further away from each other. Now, the vehicle will attempt to do this anyway, but what you're able to do is to set this as a specific function, and meaning the car won't be interrupted, and it can really try and recover some additional energy back just by balancing the cells correctly. And what's the end game? It means that the customer is looking at getting a little bit of extra range back because now they can store more energy in the battery. So it's small functions that we can run, we can offer to customers to say, you know, how's the range at the moment? How's the range doing? Maybe we could run a function like this and try and recover some of your range after doing the health check on the battery. We're starting to see the voltages, the min and max starting to creep away from each other. We can run a function on this vehicle to try and bring them sort of really back together. Excuse my Skype phone going off there. Okay. So it just gives you a couple of ideas really on just going through all of those there. It sort of gives you an idea really on the new tasks that we're going to be doing on these vehicles, you know, from a safety perspective. And to do this really as a workshop and as a business, you're going to need to be equipped with three things. You're going to need the right equipment, whether that's diagnostic, whether that's lifting equipment for either removing batteries or just lifting the vehicles themselves. We're hearing a big number at the moment of MOT stations which are struggling with cars like the Tesla Model X, the Audi e-tron, the I-Pace, because even the lifting points are too wide for their normal beam jacks. So equipment in general. We're going to need some personal protective equipment and the correct tooling, the safety tooling, the ones that's insulated, especially when you're working on systems that are live. And to go with both of those, you're going to need the correct training, not only to make sure that you're safe, but also to make sure that your garage stays with the times and actually continues to earn money. Because as I said before, that's really what it's all about. Now, what about if you don't train? Well, you're going to misunderstand the system. You're going to see an anti-roll bar system and not even realize that it's got a DC inverter inside, dropping the voltage down. You're going to potentially miss items during servicing, as we just spoke about on the battery health check. And you've got to really give customers the confidence. We have to assume now, and we do a lot of market research on this with our category team. Customers will generally, and this isn't every customer, but this is a good proportion. Customers will assume that a garage cannot do hybrid and electric vehicles, even if they've been with them for years and years. Some customers we looked at, they wouldn't even ask. They just said, oh, I don't, my local garage doesn't do that. So you're going to have to give them the confidence to be able to do that. Obviously, when you're qualified, you've got the knowledge and skills. You've got that industry recognized standard across the board. You appear on the IMI's TechSafe register, which I'm a firm supporter of, because I wish we could do it for every system, not just hybrid electric. You know, I wish you could do it for brakes, but at least we're on there for high voltage and moving over to driver assistance systems. And it really is just going to give you the confidence to service and repair. And I'm of the real ethos that me personally, I'm always learning. I'm always reading technical posts. I'm always reading different articles in magazines with common faults, because as a training organization, but also personally, I need to just make sure that I'm always with the times, I'm always on top of what's going on. And you can never be 100% fully trained. It's one of those things that it's a continuous learning program, really. And that brings us to the end. So I do appreciate it's been sort of 40 minutes. Thank you for listening to me drone on. And hopefully I've given you a few little tips and tricks and sort of new items to sort of think about when you're servicing and repairing this new propulsion technology. Thanks a lot.
That was brilliant. Thanks so much, Phil. Speaking of learning as well, this does qualify as CPD, so make sure you log this webinar as part of your CPD on your portfolio. So we're just going to have some questions. We did actually get a question in before we started the webinar, which was, my workshop is looking to kind of start out with electric vehicles. So which IMI level is best to start with?
Yeah, it's one that comes up a lot. So I think if you're a workshop that's going to be servicing, maintaining, repairing, then start with level 3. I know we offer a level 2, sort of 2 and 3 combined, because the levels 2 and 3 are actually fairly similar. And I'm talking about the full level 2, not the hazard one that we looked at earlier. So level 3 is a very good starting point. It gives you a real good introduction to it. It gives you the confidence to disable a vehicle and start replacing components and start to look at some of those features we looked at the diagnostic tool in a little bit more detail. And it's the first stepping stone really for me into sort of service and repairing. And I think once you've got that, you can then begin to sort of advertise your business that we are on the path to do this and we're ready for the vehicles.
Perfect. Okay, so we just have 2 other questions. Oh, great session, guys. Thank you, Paul. How can I book onto a course?
So, I mean, the easiest way from this sessions is we're an IMI CPD partner. So Delphi Technology, you can't come on a course directly because we only sell training like we sell parts, which is through a distributor network. So 2 choices: you can either go and see the IMI directly and they'll book you on through Delphi, or you can go and see your local parts factors. But the IMI is probably the easiest route to do that. And then you'll be coming on a course in this training center here. We also offer the ability to come to you for level 3 only. We don't offer it for level 4 because of all of the safety equipment. So both of those are an option to go and speak to the membership team. Perfect.
We'll include the details from the membership team in your follow-up email when we email you the recording. So we have one. I have a level 2 on hybrid and EV in brackets Bosch program. Can I move to level 4 directly?
Good question. What we will probably do from our side is we would do a skills test first, just to make sure that you're at the correct point with your level 2 and you've retained some of that knowledge. And if you pass that, then we can have a bit of a chat with you. But I think that's something we could do, yeah. It's not something we would like to do, so we would have a proper chat with you first and talk through some of those features and functions, just to make sure that you're up to speed, that's all.
Perfect. And Luke says, I'm from an alternative provision teaching learners level 1. I am my age range 12 to 16-year-olds. Both mechanic tutors here are CAVA assessors and have level 3 IMI quals. Would the course be suitable for our 2 tutors too?
Was that a level 3 course or the 4, Georgia, did it say? Or if the person could put on?
So both mechanic tutors here are CAVA assessors and have level 3 IMI quals. Yep. Would the course be suitable for our 2 tutors to do? So it doesn't say anything about level 4. Okay, so yeah, we've done, in fact, we've actually done quite a lot of college trainers. So we do a kind of a train the trainer sessions. We've done it with multiple colleges now, up and down. And what we're finding is some colleges anyway. I mean, I'm ex-college as well, so I get the financial issues. Some colleges have been given funds and then they've decided to either buy vehicles or they've decided to buy some of the training rigs, which are available from different suppliers. And quite a lot of them now have come through level 3 and level 4.
If you've already got your level 3, you can go straight to level 4. Some of it, it's not always necessary to teach their students level 4, but it's so that they're confident and they can also answer some of those extra questions maybe that they would have had to have missed previously. So, but yeah, coming straight to level 4 if you've got your level 3 is no problem at all.
Perfect. And is this possible doing it mobile? And Sean also put looking at safety, going more mobile, is it wise?
Yeah, so with the mobile, we only offer level 2 and 3. Well, we do 1 as well, mobile. And the idea behind that is that we bring the vehicle, all of the safety equipment, and we vet the centre first to make sure that what they've got is suitable area. So for us, doing 1, 2, and 3 is very easy to do. You know, we're well practiced at it. We bring all of the safety equipment with us, all the PPE, the vehicles, and everything else. Level 4 is more difficult because we have a lot of lifting equipment where on a level 4, we will actually take the battery out from under an electric vehicle. So that battery weighs just excess of 300 kilograms. So we need a lot of special lifting equipment, which means that we do not offer level 4 mobile, but the previous levels, it's fine. It really is. We're well practiced.
Perfect. And just one more question. How do I contact the IMI to chat about the courses? Level 4 question earlier. So what we'll do, Petros, is we will email you the contact details for the IMI membership team. And then you'll be able to touch base with them and they can support you in, you know, finding out more about our courses. Oh, and Sean has just put, sorry, as a mobile mechanic.
As a mobile mechanic, sorry, right. So that is more difficult. But what we have to look at is some OEs now are also offering mobile service. So they will come out, and I'm thinking Tesla to begin with, because they offer a mobile service. We've got some of the aftermarket garages now offering mobile service. Obviously, trying to power down a hybrid system with your gloves on in the rain is not ideal. But you have to just pick what's kind of right for you. But I think we will actually see a shift of that ability to have mobile service because it's really convenient, where you just at work, the technician comes to you, they can carry out certain elements of repair on site. And actually that's probably more than you can do with a combustion engine because it's not as easy, it's not as difficult to get rid of all the oils and stuff because you just don't have them and you're not replacing them. But I think you have to be selective with mobile repair. So if you are doing that and to power down the system and to work on something else, I don't see it as an issue. In fact, I see it as a big convenience. You know, as long as you're safe while doing so. Might look slightly odd if you're out in the street with all the barriers and everything on, but that's what you've got to do, and then that's what we do.
Perfect. Okay, great. I think we have gotten through all of the questions. I'm
surprised, Georgia, there's no questions on hydrogen fuel cell. That's the one I get asked about the most. What's the future of hydrogen fuel cell battery electric vehicles? But
what is the future of hydrogen electric fuel cell then?
So I mean, Delphi and Borg Warner, we're a huge supplier of diesel to heavy goods. So around about 40% of the trucks on the road will have a Delphi diesel fuel system on. It's a lot less for light duty, but for heavy goods, we're a huge player in that. So this is Volvo and Renault and Mercedes. Most of those will have a Delphi fuel system. But actually, we've recently purchased 2 battery companies, which specialized in commercial vehicles. So if I had to give you my personal opinion rather than the company opinion, it would be that most light duty will become battery, electric, fully electric vehicle. All of our short drop van stuff will be electric. And then the most likely outcome will be a lot of our commercial vehicles, heavy goods, will probably become hydrogen fuel cell. Now, hydrogen fuel cell has its problems. It's not nowhere near as efficient, but at least in theory, you can do it with a good proportion of renewable energy. But only time will tell. That's personally my gut feeling where we stand today. But if anyone tells you they know, they're probably lying.
Yeah, brilliant. Okay, and Charlie's just said, incredible session, thank you. It really was. Will the recording be available? Yes, it will. So we will be emailing everyone who registered to this webinar and attended this webinar with the recording link and link to a survey, and also those details for the IMI membership team if you want to inquire about courses. just one last question, and then looking at the time, we really need to sign off. But what about the future for e-fuels? It's a good one from Gordon.
Yeah, no, it is a point. I mean, you know, was it Porsche, part of the VAG group, have talked a lot about synthetic fuels, even around synthetic fuels about racing, because for those that watch Formula E, it has its other benefits, and they've had to do with Formula E. They've had to do lots of cool things, like when you're driving around the pack, when you're driving around the track, you pick up boosts on the track. It's a little bit computer game, but the reason they've done that is because some of the fact that there's no noise from the vehicles takes away a little bit from that racing sort of heritage. So my honest answer is I don't know with synthetic fuels. It really depends on how much energy is used to make them. And I think we will always accept that when we're looking at racing, that we're not doing racing for efficiency, we're doing racing as a sport for fun. And, you know, if we can concentrate initially our efforts on the wider transport, whether that be commercial cars and bikes and everything else, hopefully they'll save that last bit of enjoyment of racing, whether that be rally or Formula One or something else. Fingers crossed.
Perfect. Okay, and just to answer John's question, will there be a CPD certificate? Unfortunately, we don't do CPD certificates anymore for these sessions anyway, but if you are an IMI member, then you can log the session on your personal online CPD log through your membership portal. Perfect. Okay, well, again, thank you all for joining us, and thank you, Phil, for a fantastic presentation. Keep a lookout for future IMI webinars. We will hope to have some more up there very soon. But until then, thank you and have a great afternoon.
Thanks a lot.
Thank you very much. Bye.